Hi there, I have an interesting recurrence relation inequality problem for you, and let's see how we can solve it. So I have for each n greater or equal than 0 this inequality, and I need to show that for each an plus 5 is greater or equal than an minus 5. So let's look at this part. So this is what I want to show, and this is of course for n is greater or equal than 5 because I'm defining it for an's greater or equal than 0. So let's square both sides. Okay, this is what I want to show. An plus 5 is greater or equal than an minus 5 to the fourth power. So if you look at here, I'm going from plus 5 to minus 5, which is 10 difference, and I'm going from the power of 1 to 2. So this is actually equivalent to saying that an plus 5 is greater or equal than an squared. Why? Because now if I just do the expression again, so I'm just putting n is equal to m minus 5, and I'm squaring this expression. So this will be, I'm just putting n is equal to m minus 5, an minus 5, and I'm squaring this thing. This is to the power of 4. So this is true if and only if this is true. So if I can show this inequality, this will imply that this is also greater or equal than this, and this will imply my question. So I want to show an plus 5 minus an squared is greater or equal than 0. If I can show this, this is equivalent to showing my problem. Okay, so my task is to show this. And let's see how we can do this. So I'm writing this main statement given in the question. I'm just throwing this an squared on the left side. This is greater or equal than 1 over 2. So this is from my question, okay? And I need an plus 5 minus an squared, but I only have an plus 1. So let's rewrite the same expression. I'm just putting n is equal to n plus 1. So I get n plus 2 minus an plus 1 squared greater or equal than, again, this part is of course same. So if I just keep doing this for n plus 3, n plus 4, and n plus 5, an plus 5 minus an plus 4 squared, this is also greater or equal than 1 over 2. So I expanded this thing 5 times. Because now if I just add everything up, I will have an plus 5 and an minus squared. So I have this thing and this thing. So let's see. I'm throwing everything else to the right side. And so on the left side, I have an plus 5 minus an squared, just like how I wished. In the end, I want to show this is greater or equal than 0. Okay. So on this right side, I have greater or equal than. All of these an plus 1, plus 2, plus 3, plus 4, they are going to be minuses. Okay, so I have minus an plus 1, an plus 2, up to an plus 4. I also have all of these an plus 1 squared, an plus 2 squared, up to an plus 4 squared, and all of these are going to be positive. So I have plus an plus 1 squared up to an plus 4 squared. And I also have 1 over 2, and this is going to be 5 times because I have n plus 1, 2, 3, 4, 5. So this is just going to be 5 over 2 plus 5 over 2. And let's see what can I do with this right side. Okay, so this was a bit long. It's why I wrote them on 3 lines, but I could just write it on the same line. So I have something squared and something by itself, but this is minus. So I can say this thing is going to be equal to an plus 1 minus 1 over 2. I'm just completing it to square. So if you expand this thing, you will get an plus 1 squared minus an plus 1, which I have both of these, and this will also give me plus 1 over 4. So if I just add minus 1 over 4, I will get this these two terms, okay, with their signs. So I can just do this for all of the other terms for an plus 2, 3, 4. So this will be plus, same thing for an plus 2, minus 1 over 2, to the power of 2 minus 1 over 4. So I have this for plus am plus 3 and also plus am plus 4. Let's also write this. 1 over 2. I wrote all of them. So I wrote everything on these two lines, and I also have plus 5 over 2. Plus 5 over 2. So now I have many terms that is just squared, and I know everything is squared is just greater or equal than 0. So for all of these 4 terms, I can say they are greater or equal than 0. And also, what do I have for the remaining terms? I have minus 1 over 4, minus 1 over 4, minus 1 over 4. So this is just 4 times minus 1 over 4, which is just minus 1. And I also have plus 5 over 2. And if I just do this operation, this is just 3 over 2, which is greater or equal than 0. This is technically just greater than 0, but I just wrote it greater or equal than 0 to make it similar to my question, because my task was to show this was greater or equal than 0, and as you see, I showed it. So this is equivalent to saying this thing is true, so this is equivalent to saying this thing is true, and this is equal to saying my question is true, and that's the end of it.